your credit card, your transport card, your access badge, they all have one thing in common. They use RFID technology. Today on Electro&science, we are going to understand, wire, program and test the RFID RC522 module with Arduino step by step. No shortcut, no magic, just real electronics.
Hello there. Welcome back.
RFID is not just a obvious topic. It's widely used in banking systems, transportation networks, secure buildings, and industrial automation. By the end of this video, you will be able to read RFID cards, understand how SPI communication works, and use UID data in real-world projects. This is not about copying code, it's about real understanding. What is RFID? RFID stands for Radio Frequency Identification. The RC522 operates at 13.56 MHz, which belongs to the high frequency RFID band. The reader generates an electromagnetic field, and when a passive RFID card enters these fields, it gets powered wirelessly and responds by sending its data back to the reader. No battery, no physical contact, just feel it. Not all RFID systems are the same. Low frequency systems operate at 125 kHz and typically used for short range and simple access cards. High frequency system operating at 13.56 MHz, including the RC522 module, NFC and bank cards. Ultra high frequency system operating between 860 and 160 MHz as used for long range applications such as logistics and tracking. Today, we focus on high frequency RFID because it is the most versatile option for Arduino projects. Let's take a look at the RC522 module. It contains an RFID transceiver and copper antenna and built-in logic for SPI communication. One very important warning: this module doesn't work at 5 volts. Supply 5 volts can permanently damage it. Always use 3.3 volts. The RC522 uses SPI communication. SPI stands for Serial Peripheral Interface. It uses 4 main lines: MOSI, MISO, SCK, and SS. MOSI is used to send data from the master to the slave, while the MISO sends data back from the slave to the master. SCK provides the clock signal, and SS is used to select the slave device. In this setup, Arduino is the master and the RC522 is the slave. SPI is fast, reliable, and perfectly suited for RFID communication. Let's now connect everything. The SDA pin is connected to the digital pin 10 and the reset pin is connected to the digital pin 9. MOSI is connected to pin 11, MISO to the pin 12, and SK to the pin 13. The red LEDs is connected to digital pin 2 through a 220 ohm current limiting resistor, and the green LEDs is connected to digital pin 3 through another 220 ohm resistor. Power supply use is 3.3 volt only, and the ground is connected to the ground. Always double check your wiring before powering your circuit. Now let's understand the code. We start by including the SPI and MFSC 522 libraries. Then we define the required pins and initialize the RFID reader. Inside the main loop, the program checks if a card is present. If a card is detected, its UID is read and printed in hexadecimal format. The UID is unique for each card. This UID is the key to identification. Let's test the system. I open the serial monitor at 9600 baud rate. When I place a card near the reader, the UIDs appear instantly. When I change the card, the UID also changes. This confirms that our system is working correctly. Now let's create a simple project. We place the card UID inside the authorized UID array and upload the code to the Arduino Uno. If the scanned card has the same UID as the one stored in the program, the green LEDs turn on for 3 seconds. If the UID doesn't match, the red LEDs turn on instead. Let me warn you about some common mistakes. Using 5 volts instead of 3.3 volts is one of the most common errors. Forgetting to insert the RC522 libraries can prevent the code from working. Incorrect SPI wiring and low quality jumper wires can also cause unstable behavior. About 90% of RFID problems come from these issues. Now imagine what you can build with this knowledge. You can create a door lock system, an attendance system, an RFID based safe, or Arduino relay access control system. This small module is capable of powering serious projects. Electronics is not about magic, it's about understanding system. And today we have taken one more step forward. If this video will help you, support the channel by subscribing. This is Electro Science. Learn deeply, breathe intelligently. See you next time.